I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Hyderabad. In this session, we are going to discuss about remote procedure calls and sockets. Remote procedure call is the one type of inter-process communication for sharing the information among multiple processes. So for this topic, we can follow the textbook is Introduction to Embedded System by Shibu KV. Publisher is Tata McGraw-Hill. So remote procedure call is the inter-process mechanism used by the process to call a procedure of another process running on the same CPU or different CPU, which is interconnected in a network. Means we can share the information between different processors which are running on the same CPU or different CPU. So this procedure is called remote invocation. So means we are calling the procedures or some functions, some requirements from remote location. Okay. So we can access Hotstar or different apps from the remote location based on our requirement. So it is mainly used for distributed applications like client server applications with client server means whoever send the request, those person is called client. Who is providing the services that is available in the server, so that is server. Okay. So with RPC means remote procedure call. With remote procedure call, it is possible to communicate over a heterogeneous network, means different types of CPUs. Means network where client and server applications are running on different operating systems. Next. So CPU or process containing the procedure which needs to be invoked remotely known as server. So whatever the requirement is there, that is defined in the some program, that program is stored in the server. So if you require that program or if you want to execute that instructions, so we can call that requirements by using function calls. So the process which initiate an remote procedure call request is known as client. Suppose I am using Gmail. That Gmail database is available in corresponding Google servers. But I am accessing my Gmail account from my location. So I am the client. So that server is available in some different locations. So like this. So this is one device that contains corresponding CPU 1. I am taking another device that is contains CPU 2. Okay. Here CPU 1 contains process 1. CPU 2 contains process 2. Whenever process 1 wants the process 2 or process 1 require the information from process 2. Okay, at that time it will call this process 2 by using system calls. Okay, which both are interconnected over the Ethernet or Wi-Fi, like that. So by using remote procedure call, we can provide the communication among two processes which are running on different networks or different operating systems or within the same CPU. Okay. So it is possible to implement a remote procedure call communication with different invocation process interfaces. In order to make the remote procedure call communication compatible across all platforms, so it should be stick on to certain standard formats. Means if you want to support any interface, suppose I'm taking new device like new hard disk, scan disk, or SD, WD, different manufacturers providing different types of flash memory devices. When I connect that hard disk to my desktop, it needs to be supported. Okay. So if you want to interact with different process, at that time we need to access that one and provide the communication, and that is defined in particular standard formats that have some procedures or that have some rules and regulations to accept the all the interfaces. That is called interface definition language. Interface definition language. Example, Microsoft interface definition language, that is implement the remote procedure call for all Microsoft applications. So this remote procedure call can be either synchronous or asynchronous. Synchronous means whenever the process sends a request, it is waiting for response or acknowledgement from the server. Then only until that one, this process comes into the waiting state or blocked state. After getting the acknowledgement, then only it will continue its execution. That type of communication is synchronous communication. Asynchronous means the process sends a request to another process but does not waiting for any acknowledgement from the server. It continues its execution. Okay. In the synchronous communication, the process which calls the remote procedure is blocked until it receives a response back from the other process. So until getting the response, whatever the process send the request, that process is the client that is in the waiting a blocked state. In asynchronous remote procedure calls, the calling process continues its execution while the remote process performs the execution of the procedure. The result from the remote procedure is returned back to the caller through the mechanisms like callback functions. So security purpose, if you want to establish the communication, the server authenticate the client, then only the server grants the services. Otherwise, it does not grant the services. So on security front, remote procedure call employs authentication mechanism to protect the system against different types of vulnerabilities or malfunctions, malware, phishing attack, or different types of malwares that will come. Okay, we are getting different types of cyber security issues. So the client applications should authenticate themselves with the server for getting access. So client provide the authentication information to the server to get the services. Authentication mechanism like it will give IDs or public key or extra so on, used by the client for authentication purpose. Without authentication, any client can access remote the procedure means that may lead to security issues. Everyone will access means the data may be corrupted, or the confidentiality may be lost, or integrity will be lost, or availability is different. So here we are using sockets. So suppose this is CPU. This is machine 1 and machine 2. So this is device 1 or CPU 1. If you consider this is CPU 2. So each one contains sockets to interact with the other peripherals or other devices. So this socket contains internally port 0, port 1, port 2 like that. Port 0, port 1. So this socket has some number and internally the port has particular number. So sockets are used for remote procedure call communication. The socket is a logical endpoint in a two-way communication link between two applications running on a network. A port number is associated with the socket so that the network layer of the communication channel can deliver data to the designated application. Okay, if you want to access particular server, so each one has particular name. Server name is either Google server or client is whatever process 1. Suppose it is process 1, it is process 2. Here we are giving port 0, 1, 2 of CPU 1. This is also port 0, 1, 2 of CPU 2. Whenever it is interacting with that one, it will send the server name CPU 2 port 0. CPU 2 port 0 or CPU 2 port 1. CPU 2 port 2. Like that. Whenever the server, after getting the request, it will authenticate that CPU. Is it valid or not? Or is it any suspicious activities are there? If it is authenticated, then it will send the information to the client, like the for CPU 1 port 0. It will send the information to the CPU 1 port 0 or CPU 1 port 1, CPU 1 port 2. So sockets are of different types, named as internet sockets or Unix sockets, like that. These internet sockets are work on the principle of internet protocol. This is called, if you shortcut is INET. Works on the principle of internet communication protocol. Example TCP/IP or UDP. User data graph protocol. Okay. If these are two types, this internet protocol is two types. One is stream sockets, another one is datagram sockets. Stream means bulk data will transmit, datagram means packets will be transmitted. Stream sockets are connection oriented and they use TCP protocol to establish a reliable connection. On the other hand, datagram sockets are rely on the UDP for establishing the connection. The UDP connection is unreliable when comparing with the TCP protocol. So the client server communication model uses a socket at the client side and the socket at the server side. Total two sockets. Client side one socket, server side another socket. A port number is assigned to both of these sockets. The client and server should be aware of the port number associated with the socket. In order to start the communication, suppose if you want to interact with particular person, we need to know the corresponding person details, either name, destination, address, or contact number or ID number, whatever the details we are required. In order to start the communication, the client needs to send the connection request to the server at the specified port number. So CPU 2 port 1, that is the specified address. The client should be aware of the name of the server along with its port number. So to which device or to which server the client wants to connect, that needs should be aware. We have information regarding that one. The server always listens to the specified port number on the network. So different devices or different clients send the request to the server. Different so many requests will come. So it always listens that request and responds as per requirement. So upon receiving a connection request from the client, based on the success of authentication, if it is valid, the server grants the connection request and a communication channel is established between the client and server. The client uses the host name and port number of the server for sending the requests. It contains host name, that is CPU2, port number 2, port number P2, host name CPU2 of the server for sending the request, and server uses the client's name like CPU1 and port number port21 for sending the responses. Like that, by using this we can see some examples. So first, include stdio.h standard input and outputs. Here we are creating Windows sockets. WinSocket means Windows sockets. So Windows system TCP/IP protocol. So here we need to specify the server address 172.168.0.1 for interacting with particular server. At the same time, here we are defining some port number, that is define port particular number we are assigning. Next, Win32 library we are taking here for Windows Win32 OS. The OS name is Win32 OS name, operating system name. Here we are taking some variable. So receiver buffer length. So the receiver buffer size should be limited, either something 100 or some units of amount. Within that only it will receive the request. More than that one means it will reject. So it send the request hi from client, send buffer. So after receiving, based on the buffer length. So first initialize the main function for start of execution. Here initializing the Windows socket, that is Windows socket data. If there are no errors means the Windows socket initialization is succeed. Otherwise the communication is not established, means failed. Next, connect a socket for connecting to server. So socket, my socket. Here we are creating some variable. Then we are writing some function. IP prototype is TCP. Socket is stream type socket. The protocol is internet protocol. Internet sockets. In internet sockets, that is stream type, like that is using TCP/IP protocol. If it is invalid means socket creation is failed. Next, clean up the Windows that activities. Else, successfully create the socket. Like that, we can mention the socket type, IP address, port of the server. Next, socket address in server parameters, like we are taking internet sockets. Okay. So if internet protocol is failed, that is fail here. Print that statement, that is failed. Otherwise, here connection is established. We are connecting to the server. Then in this function, if it is we are getting any error means connection is failed. Connecting to server is failed. Else successfully connected to the server. Then send the command to the server. If send my socket, send buffer length, initialize a string length and send buffer length. If it is any error means that is failed. Else successfully send the command to the server. then receive the data packet. So receive my socket, receive buffer length greater than 0. So buffer weight availability is more than 0 means then only we can receive the response. Like that, we can provide the communication among various processes by using remote procedure call function, either both processors working on the same machine or different machines. Next, one of the topic is host machine. Host means the system on which we can design the desired embedded system. Example, I want to design a basic mobile phone. If I want to design a basic phone means first I need to find out the requirement. What are the features I want to provide in that basic phone? Either voice calling, text message, time, calendar, games, basic games, or some features. Based on the features, I need to write the instructions for that one. So, based on the instruction, based on some other parameters, we need to consider either speed. If you want to provide more speed means, we need to use hardware circuits to provide more speed. But if you are using hardware circuits means, the size of the components increases as well as cost of the product will be increased and power consumption increases. But if you are considering only speed means that is not a matter. But if you consider cost also, cost, size, power consumption, if these parameters are very important means the same functionality will be defined in the instructions form. And we are using corresponding processing element. So which processing element is suitable for doing these operations? Either 8051 or 8086 or dual core processor or core i7 processor, which one is best with reasonable cost? So first we need to choose the processing element. Based on the processing element, the supplier or manufacturer provide the corresponding IDE tools. Suppose I want to design the applications on 8051 based processing element. This manufacturer, Intel 8051, provides the Keel IDE tool. This Keel IDE tool is installed on the desktop computer. So, here desktop is the host machine. In this desktop, I install the Keel IDE tool and design my requirements. Then it generates the X file from this software tool. That X file is loading into the physical hardware to do the desired operations. So here desktop is the host machine. Host machine means the system on which I can design my desired requirements. Example, desktop computer. Next, target machine. Target means the desired embedded system is called target machine. Like mobile phones, smart cards, or whatever may be. All embedded systems are the target system. So the desired system is called the target system. This is called host and target machine concept. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.